Today's lesson is on discrete and continuous domains. First, we'll look at our key idea for discrete and continuous domains. A discrete domain is a set of input values that consist of only certain numbers and an interval. For example, we can do the integers from 1 to 5. So this would be our whole numbers, 1, 2, 3, 4, and 5. A continuous domain is a set of input values that consist of all numbers in an interval. For example, we can do all numbers from 1 to 5. So this would be all of our numbers from 1 to 5, which includes the numbers in between 1 and 2, 2 and 3, 3 and 4, and 4 and 5. So again, this was all the numbers from 1 to 5. Now we'll look at graphing discrete data. The function y equals 15.95x represents the cost y in dollars of x tickets for a museum. Graph the function using a domain of 0, 1, 2, 3, and 4. Is the domain of the graph discrete or continuous? And then we'll explain. So first we're going to make an input-output table. We're going to use the domain of 0, 1, 2, 3, and 4. So this would be our input, or the x values. We're going to plug these into the function, and then we will get the output, or the y values. So if we use 0 for x, 15.95 times 0 is 0. So y would equal 0. Our ordered pair would then be 0, 0. If we use 1 for x, 15.95 times 1 is 15.95. So the ordered pair is 1, 15.95. If we use 2 for x, 15.95 times 2 is 31.9. So the ordered pair is 2, 31.9. If we use 3 for x, 15.95 times 3 is 47.85. So our ordered pair is 3, 47.85. And then if we use 4 for x, 15.95 times 4 is 63.8. So the ordered pair is 4, 63.8. Now we're going to plot the ordered pairs. So we'll go ahead and plot the 4 ordered pairs. So first we had 0, 0. Then we had 1, 15.95. 2, 31.9. 3, 47.85. And 4, 63.8. Since you could not buy part of a ticket, the graph would only consist of those individual points. So the domain is discrete because we would not be able to buy part of a ticket. We either buy 0 tickets, 1 ticket, 2 tickets, 3 tickets, or 4 tickets. Again, we cannot buy part of a ticket. So therefore, the domain is discrete. Now let's look at graphing continuous data. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Graph the function. Is the domain of the graph discrete or continuous? So we're going to make an input-output table. So our input would be our B, which would be the number of bars eaten. The output is C, which is the number of calories consumed. And then we get the ordered pair, which would be in the form of B, C. So if we eat 0 bars, we have 0 calories. So that ordered pair is 0, 0. If we eat 1 bar, we would have 130 calories. So the ordered pair would be 1, 130. If we eat 2 bars, we would have 260 calories. So the ordered pair would be 2, 260. If we eat 3 bars, we get 390 calories. So the ordered pair would be 3, 390. And if we eat 4 bars, we get 520 calories. So ordered pair would be 4, 520. So now we'll plot the ordered pairs. So we have 0, 0, 1, 130, 2, 260, 3, 390, and 4, 520. Because you can eat part of a cereal bar, B can be any value greater than or equal to 0. So we would draw the line through the points. So for this one, we would draw the line because we can eat part of a bar. So we could eat just half of a cereal bar and find the number of calories in just half of the cereal bar. So since we can eat part of the cereal bar, then we would have a continuous domain. So the domain would be continuous because we can have part of the serial bar.